Hey, what's up guys? Welcome to the Mr. Fix-It channel. Working with my Logan Model 210 here, I want to talk about cutting metric threads using the original set of change gears and not having to buy any extra gears. Now this is the video that I tried to find when I went down the rabbit hole of cutting metric threads on an Imperial lathe. Now to my subscribers, this video is going to be off topic from my normal content, but you may find it interesting, so stay tuned.
I was sitting out there in the shed one evening, not doing too much of nothing, just kind of staring at the wall. And
Okay, so this is my Logan Model 210. Now this is going to be relevant to all the 200 series Logan lathes. You change gears go in here, and you get a set of 17 gears that come with this lathe. Now inside this cover you're going to have a threading and feeding chart. This chart is quite a bit hard to read, so what I did is I printed this out of the manual and I put it on this index card and I've laminated so I can keep it higher in the shop so it's much easier to read. Now I'll put this up on the screen so you can see it if you do not have this threading chart for your lathe. So if you look close here, you can see we can cut all sorts of Imperial threads. We also do have several feed rates that we can use. Now as an added bonus to this video, I want to talk about the finest feed rate of this lathe is basically 4.5 thousandths, or 0.0046 thousandths of an inch for every rotation of the spindle. Now you can get a finer feed than this that's in this chart. So here's a chart that I had made to cut the metric threads on this lathe using the original change gear set, and I'll also flash this up on the screen so you can have a good view of it. You can even pause the video and take a screenshot. You can have it for yourself. I also come up with a ultra fine feed rate of 3 thousandths per revolution, and I put it in this chart, and this is this figure here. So when you talk about cutting metric threads on an Imperial lathe, you have to thread a little bit differently, as in you have to leave the half nuts engaged. Now working up towards the chuck or working up against the shoulder, you have to shut the machine off and let it coast to a stop, back the tool out, put it in reverse and run the tool back and not disengage the half nuts. But I'm going to show you a little trick that I learned off another guy on YouTube to where you can disengage the half nuts when working close to the chuck or up against the shoulder. Now for more information about this, because you need the metric transposing gears to cut perfectly accurate threads on an Imperial lathe, this chart is going to give you approximates. Now I put these approximates down here, and this will give you how much the thread will be off per 10 pitches or 10 threads. Now you can see it's very minor of a deviation. For most of you, unless you're threading a 3-inch screw into a 3-inch nut, this isn't going to be relevant. Now where it does deviate quite a bit is on the 1.75 threads, 0.229 millimeters per 10 threads. It gets a little off, but you can work around this. Like I said, this is using the original gears without having to buy the expensive metric transposing gears. So I've done the most common metric threads, the 1, 125, 150, 175, and the 2.0 threads here. And I'm going to show you the website that I use to calculate this, and we're also going to cut some threads, and I'm going to show you how accurate this can be. Alright, so the gears I have installed on here now are for the ultra fine feed. This is going to be giving me 3 thousandths of an inch of carriage travel for every one rotation of the spindle. So you can see how I have them arranged here. I've already got a piece of stock chucked up in the lathe, and now I'm going to turn this down to the major diameters of each of these threads. I'm going to do 6 millimeter, 8 millimeter, 10 millimeter, 12 millimeter, and 14 millimeter thread. Alright, so I'm going to cut 5 different metric threads. Here's my 6, my 8, my 10, my 12, and my 14. I'm going to use these as a nut. I also have a thread indicator, but my thread indicator doesn't go up to 2 millimeters, but I will be able to use it for these 4. Give me a few moments. Let me turn this down to all the major diameters of all these threads, and I'm going to use the ultra fine feed, and it is a pretty fine feed. It makes a really nice finish, especially in this material. This is all thread that I had turned down here just to use as my stock. Now I want to add a little bit of a disclaimer here. I am not a lathe expert. I only dabble in this stuff. I do have some experience, and I have done a lot of research on how to operate a lathe, but like I said, I'm not an expert, especially on thread cutting. So just so you know, it is January, and I do have my heater running, So you're going to hear this in the background. Hopefully this is not too much of a distraction. Now I know I'm wearing long sleeves around this lathe, but believe me, I'm just being careful. It is cold. I'm going to turn this down so far to the major diameter of 14 millimeters all the way across, and then I'll step this down. So let me start here. Now all my micrometers and all my measuring equipment is all an imperial standard. So I'm going to be using my digital calipers here as a conversion. So I need to take about 200 off of that. I'm not going to show a bunch of this because it's very tedious and repetitive, but I will show you how fine the fine feed is here. All right, let me get everything set up, make sure my carriage is traveling the correct direction. Zero out my dial. All right, here we go. It's 40 thousandths depth of cut. Material cuts like stainless. I believe it is stainless. It's very stringy. Okay, I got the stock prepped. I got it undercut, and the M6 threads down here, I may have to set up a steady rest because, you know, I'm into my live center there, but I'm going to start with the 2mm 14 right here. So I'm going to look at this chart, 2mm, figure 1, so it's going to be arranged like this. I need these gears. I'm going to go ahead and put these gears on. Alright, so according to this chart, I need a 32 on the stud gear, so we'll grab a 32, line up the key there wherever it's at. There we go. And for the screw gear, I need a 60. So find my 60 right there. And also notice that the spacer is on the inside there, according to the dashed line. So spacer on the inside. And then the compound gear, I need a 44 in the A position, it'd be on the inside, and a 52 on the outside. So I'm going to take my stud bushing and grab my 44. That's in the A position on the inside. I'll wiggle this guy on here. And then the 52. Now it is necessary to put a spacer, a thin washer spacer, which should come in your gear change kit, in between these gears so that they don't rub. So we'll put that in there. I mean, this is standard for all your gear changes, so you've got a manual to your lathe and all this will be in the manual there. So this will be the compound gear setup. Alright, this is going to look like that. That should be set up to cut 2mm. And we'll start right here. So this is not a thread cutting tutorial. There's plenty of videos on the internet of people way better than I am about threading. But I'm going to show you the trick where you can disengage the half nut when you're threading up to a shoulder. So I'm going to get my dial set here to 0. And we'll start threading this. Okay, now I'm going to use the number 1 on my thread dial just so I can remember what number I'm using. So I'm always going to use number 1. So engage it on number 1. Do a scratch pass. And as I come up to the shoulder, what I'm going to do, when I get into my gutter, I'm going to disengage the half nut and I'm going to shut the machine off. And the 1 moved a little bit out of the way, so now I'm going to reverse the machine. I'm going to pull the tool out of the work. I'm going to turn the machine on, and I'm going to re-engage on that 1 again as the as the carriage backs up. So it's coming back around to 1, re-engage 1 again, and let it back all the way up. And that's the trick. So you disengage the half nut, shut the motor off, pull the tool out of the work, reverse the machine, catch the same number that you started with on the way back out, and then leave it there. Alright, so now I'm clear of the work. I want to move back in to 0. I'm going to feed in a depth of cut, put the machine back and forward, and then start a cut. And I am feeding with the compound. Disengage, shut the machine off. Now my dial is quite worn out, so what I'm going to do is I'm just going to take a Sharpie so that you can see, and I'm going to mark the number 1 right there. I'm going to pull the tool clear of the work, reverse the machine, turn it back on, and then when the 1 comes back around, engage the half nuts and follow it back out. Once you get clear of the work, shut the machine off, put it back and forward, and now you're ready for another cut. So I'm going to dial this back to 0, and once you get it back to the starting point, you want to dial in a depth of cut, put the machine back and forward, and then start your cut again. You'll see it goes right back into the same thread. Disengage the half nut, turn the machine off. Back to tool out, flip it into reverse, turn the machine back on, catch your number on the dial on the way back. And that's a way you can do this, threading up to a shoulder, cutting metric threads on an imperial lathe. I'm going to speed this up just a little bit. Alright, turn the machine off, back to forward, come back to 0 on the cross feed, and then on the compound, add some cut. Turn the machine back on. Motor stop, back to tool out, reverse, machine on, catch the dial, reverse it back. Alright, this should be the final pass. Alright, there's 2 millimeter pitch thread right there. So I'm going to go ahead and cut the rest of these threads off camera to save you all that time and effort. And when I get all these cut, we'll come back and we'll test all the threads. Okay, for the 1.75 millimeter threads, we're going to stick with the 32 on the stud. Then we're going to have a 54 and a 52 as the idler compound gear. And on the screw, we're going to have the 56. So we're going to have the 56 here and the 32 there. That stays the same as the 2.0. So I'll get this set up and cut some threads. And this should be the last pass. Works just fine. Sorry, I'm bumping the camera around. Yeah, works just fine. So you can cut metric threads on this lathe without buying the gears. Okay, so like I said, I didn't have a 2.0 thread pitch gauge, but I do have a 175 thread pitch gauge. And that fits it actually perfectly. Okay, so we'll move on. Next one is a 1.50 pitch. Alright, so instead of cutting the 1.5 pitch, I'm going to go ahead and cut the 1 pitch 6mm so that I have a smooth place to put my steady rest. So I'm going to go ahead and cut these threads next. Okay, so for the 6mm 1 threads, we're going to go 16 on the stud gear, we're going to do a 60-52 on the compound gear, and a 44 on the screw gear. So I'll get those set up, we'll cut them threads, and we'll see if they fit. Alright, so it's a brand new day. It got late last night. This will be the final pass on the M6 1 thread. So we'll go ahead and run this one. So normally you wouldn't cut thread like this. You would have this closer to the chuck, you know, more rigid, but there, that thread's on there. There's a couple tight spots. I didn't clean it or nothing. So now let's move back up here. So what would that be? The 1.5mm thread, and then we'll finish off with that one. I may run a 3-point file through that one to clean it up. All right, let's check it with the thread pitch gauge. Yeah. Looks spot on. Alright, move on to the next. Alright, going to cut the 1.5mm next, and this is an easy change gear swap, so all we're doing is changing the stud gear from a 16 to a 24. So already got that set up. We got 16, we got a 60, a 52, and a 44, and that'll cut the 1.5mm threads. Alright, just did my scratch pass. I'll get the 1.5 out, and that looks good, so we'll go ahead and cut these threads. Alright, this is going to be the last pass. That fits good. Check it with the thread gauge just because. Yep, fits it perfect. Alright, finally the 1.25mm, we'll get that one cut. Alright, so for this thread we need 18 on the stud, and then we need a 64-56 on the compound, and then a 40 on the screw. Alright, 1.25mm, waiting for my dial to come around, we'll do a scratch pass. Alright, let's see, 125 gauge. Yep, that looks like it. Alright, I'll get these threads cut, and yet again, I'll bring you back. Alright, this is the final pass. Here we go. Alright, that's a rather odd looking part. So I hope you guys appreciate the effort it went through. This was a lot of changing gears and a lot of threading. It actually took quite a bit of time, you know, setting up cameras and trying to get all the angles and putting all this information together. I had to search around on the internet, and like I said at the beginning, this is the video I was trying to find of somebody talking about how to use the original change gear set to cut these metric threads. And I stumbled across a website. It's called a, what was it called? Something like Gear Thread Calculator, something like that. Change gear calculator, and it'll calculate from metric lathes to imperial threads and imperial lathes to metric threads, back and forth. You basically just plug in all the gears sets that you have and so on. I'll take you into the computer here in a minute and I'll show you that website and how it works. I'll even put a link down in the description, it'd be that way, and we'll talk about that, because you may not have a Logan lathe, and this could possibly work with just about any, a Clausing lathe, a South Bend, an Atlas. There's lots of different lathes out there. Now, from what I understand, the research that I have done is if you have a quick change gearbox, this isn't really going to work. It may work, but you'd have to know all the gear sets that are in your quick change gearbox and calculate that in. You may have to do something different there, but for lathes that have a standard change gear set, this website may benefit you when you're trying to cut, you know, threads. So we'll go in here to computer real quick and I'll show you that program. Alright, so this website, it comes from thelittlemachineshop.com right here, and then this will explain everything. So pause this video and read through this. Now where we're going to start here is down here in this box. We're going to click Other, and if you read this section over here, this will tell you what all you got to do. So basically in this box here, you're going to click the entire set of gears that come with your lathe. Since I've already put this in, I want to put that in there, and you're gonna put what TPI your lead screw, and on this Logan it's 8 TPI, so we're going to type 8 there. And in this box we're going to type the minimum gear teeth for the A position, so we're going to type 34 there, and this one's going to be the maximum gear teeth in that position, 88 and 48 and 36. So this is the minimum on the screw gear and the maximum on the screw gear. Now your lathe is going to be different if you have a different set of change gears, if you're not using a Logan lathe, but these are the numbers that I use. Now keep in mind that these numbers I just randomly threw in. I picked the two smallest numbers to go here, or correction, I picked the two smallest gears here and the two largest gears here, and so on and so forth. And I didn't actually go try this on the lathe first. So these gears might not physically fit in these positions. So after you get that all calculated, we're gonna go to millimeters, and we're gonna type in the thread pitch that we want. We'll just type, I'll click that one for now, and then we're gonna come over here and hit calculate. And this is gonna calculate the gears. Let me scroll down so you can see their chart here. This is gonna calculate which gears you need to put in position A, B, C, and D, and it's going to give you a couple different options, or maybe several different options, and you'll just have to pick the gear set. Now I know with my lathe, with the Logan lathe, that you can't put a bigger gear in the C position than you can in the B position because of the nut on the stud gear selection. Now you can if the gear is small enough, and that's why I made this chart to make it easier for you, but you just have to try this for yourself if you have something other than a Logan. And this is how I come up with the chart that I have made, and this is the program that I used, and this was very handy in coming up with cutting these threads. So I'm going to go ahead and change this. We'll type in 1.5, calculate. You can see it comes up with more selections here. Sorry, my mouse is being all crazy. But it'll give you selections here, and like I said, you just got to pick the best set of gears that will actually physically fit in your change gear section. And it'll show you the amount of air and percentages, and it'll show you the amount of air in millimeters for every 10 pitches. Now this is how I come up with that. And this is the website that I used, littlemachineshop.com. So if you follow the instructions in this video, then you too will be able to make the magic metric wand of screwing. Alright guys, well that's how you cut metric threads on this Imperial Logan lathe. And if you like this video, please give me a thumbs up, consider subscribing, and don't be afraid to fix it. Thanks for watching.